Welcome to aminacademy.com. In chemistry, let us discuss about characteristics of covalent bonds. In that, we will discuss about energy and stability. Most individual atoms have relatively low stability. Noble gases are the exemption. They become more stable when they are part of the compound. Unbonded atoms also have high potential energy, as shown by the energy that is released when atoms form a compound. After two hydrogen atoms form a covalent bond, each of them can have an electron configuration like that of helium, which has relatively low potential energy and high stability. Thus, bonding causes a decrease in energy for the atoms. This energy is released to the atoms surrounding. Next, energy is released when atoms form a covalent bond. Look at this figure. This figure shows potential energy changes that take place as two hydrogen atoms come nearer to one another. This first part here. The distance between the two atoms is large enough that there are no force between them. Suppose this two hydrogen atom is longer distances. That means there is no attraction force. At this distance, the potential energy of the atom is arbitrarily set at zero. Here, at this stage, potential energy is zero. And this second part, these two hydrogen atoms come nearer, make it nearer. The potential energy decreases as the attractive force, electric force, pulls the two atoms closer together. As the potential energy goes down, this happens. The system gives off energy. In other words, energy is released as the attractive force pulls the atoms closer. Eventually, the atoms get close enough that the attractive forces between the electrons of one atom and the nucleus of the other atoms are balanced by the repulsive force caused by the two positively charged nuclei as they are forced closer together. The two hydrogen atoms are now covalently bonded. Now, it happened bonding here. The two atoms have bonded and they are at their lowest potential energy. If they get any closer, repulsive forces will take over between the nucleus. Potential energy determines bond length. Here, look at this. When the two bonded hydrogen atoms are at their lowest potential energy, the distance between them is approximately 75 micrometer. This distance is considered the length of the covalent bond between two hydrogen atoms. The distance between two bonded atoms at their minimum potential energy is known as bond length. That means, what is bond length? We can explain further. The distance between two bonded atoms at their minimum potential energy. The average distance between the nuclei of two bonded atoms is a bond length. Further, bonded atoms vibrate and bonds vary in strength. For example, take the model of suppose we are having a solid roller. If you pull or pulls, it's not easy to pull or push. It won't vibrate because it's a solid. Another example, take one spring, helical spring, and pull both sides and it starts to vibrate. The models of, however, the covalent bond is more flexible, like suppose two students holding as a spring and release it. The two nuclei vibrate back and forth. As they do, the distance between them constantly changes. The bond length is in fact the average distance between the two nuclei. That means mostly that covalent bond, the atoms are vibrating in particular distances. Now bond energy. The energy required to break the bonds in 1 mole of a chemical compound. Here, the bond energy is a certain energy withheld by using covalent bond. Now, the energy required to break that bond of 1 mole of a chemical compound is called bond energy. Now further details we will discuss in future videos. We have done. Please subscribe our YouTube channel.